This time we explore just some of the many achievements of one of the world's most famous air testing grounds. We focus mainly on the breaking of the speed barrier. One of the most famous seaplanes ever built is the PBY Katalina. We investigate what made this plane so brilliant. Even though the design was aged by the time World War II broke out, it still played a major role in many theatres. Finally, we take an in-depth look at one of the most important planes in our aviation history. This aircraft is considered by the Smithsonian as one of the 12 most important planes in the history of flight. It revolutionised air travel. This is no ordinary Air Force base. This is Edwards, and it is here the extraordinary in aviation is witnessed. It is here that pilots test the absolute limits of flight and technology. In the early 1900s, the place was merely a water spot for the railway. Originally named Muir, a reversal of the name of the Coram brothers who settled the area near the Fort Rogers Dry Lake. A small community grew out of the desolation. From this meagre beginnings, Edwards was established as an aviation testing ground and has been the keeper of the legend of the right skill, known as the right stuff. It is the stuff great pilots are made of, men flying untested machines and pushing aviation frontiers. The base has been operational for more than 50 years as the official US Air Force's Flight Test Center. Pilots call it pushing the envelope, exploring the limits of every aircraft's ability. The test pilots are an elite group that are chosen from thousands of pilots for their skills, and they are the best of the best. Recently, the faithful gathered to honour that history. The base was named an historic aeronautical site. Among them was a man who survived many a near miss and went on to become one of the world's first famous aviators, Chuck Yeager. He is synonymous with the exploits of the Edwards Air Force Base. Just 5 years after America's first jet flight, Captain Chuck Yeager climbed into a test aircraft that was to achieve a significant milestone in our history of aviation. The plane was the X-1, and the milestone was supersonic flight. On October 14, 1947, the sound barrier was broken. Chuck Yeager exceeded Mach 1, the speed of sound, although this was just the start. Within 6 years, the speed was doubled, and in 16 years, man had reached 5 times the speed of sound. All this was performed at Edwards Air Force Base. Many pilots were killed in such exploits, and at Edwards, streets are named after many such men, and there are many streets at the base. Captain Glenn Edwards is an example. A display at the Edwards Museum explains how he died in a test flight in 1948, and a year later the base was named in his honour. The Base Museum celebrates what make Edwards and its pilots famous. Some pilots like Yeager flew experimental aircraft to supersonic and beyond. Others flew to the edge of space, the prelude to the space race. Yet others tested the most bizarre. Over 500 aircraft have been tested at Edwards, and always pushing aviation theories to the limits. Too often, especially during the early days of jet testing, pilots pushed too far or machines failed them. In the early days at Edwards, the newest ideas could only be put to the test for real. No flight simulators, just build it and fly it. Sometimes the unexpected occurred with disastrous results, but test pilots would argue that much was learned from this exploration of the unknown. Of all the experimental planes flown here, it is the X-planes that are probably the most famous. The X-planes were designed to smash the sound barrier. The first was the Bullet X-1. It was shaped like a bullet because everyone was aware that bullets did indeed travel faster than sound, so the shape seemed like a good place to start. On October 14, 1947, Chuck Yeager became the first human to fly through the sound barrier. Next came the X-1A. It was designed to exceed Mach 2 and continue in recording data for even more ambitious projects. On this flight on December 12, 1953, Jaeger and the X-1A reached Mach 2 and continued accelerating to Mach 2.5. At about this time, it all started to go wrong. The plane experienced the phenomenon called inertia coupling, and Jaeger lost control of the craft. You will see the plane become violently erratic. The massive forces acting on the plane toss it from side to side, and it can be best described as an extreme case of wind buffeting. Jaeger was not semi-unconscious, but did manage to recover in time to stabilise the X-1A and go on to safely land the aircraft. This is a classic example of what is referred to as being made of the right stuff. This is the view from inside the plane. From the time Jaeger lost control to recovery, the craft had fallen over 40,000 feet. When the problem was encountered, Jaeger was travelling at about 1,600 miles per hour. After further research and reviewing earlier flight data, it was found that much higher speeds could be reached with swept wing designs. This is the X-2. Not much was known about the concept of swept wings, and without the aid of wind tunnels or computer-generated models, it was a matter of build it and fly it and see what happens. The X-2 was designed to test both speeds and latitudes far greater than that of the previous X-1 planes. X-2 was flown only 20 times, but it did set many marks in aviation. Unfortunately, the X-2 project was stained by accidents, instability, and finally fatality. This is January 23, 1958. Colonel Frank Everest is embarking on a test flight that was to set a new speed record of 2.85 times the speed of sound. This was only bettered by the plane once, which was its last flight about 2 months later, when it reached a speed of Mach 3. Unfortunately, at about 2,094 miles per hour, inertia coupling was experienced. Both the plane and the pilot were lost. Colonel Everest flew the X-2 on 13 occasions. This was his last flight before transferring to other projects. The X-15 was an important aircraft that merged both flight and space travel together. It was developed to explore the identifiable problems of space and flight at very high speeds. The goal of the project was to fly at Mach 6.6 or greater and at altitudes greater than 260,000 feet. This is July 17, 1962, and test pilot Robert White is taking the X-15 to an altitude greater than 314,000 feet. Robert White was the first X-15 pilot to be awarded astronaut's wings. The X-15 project included 3 aircraft, and the project exceeded all the objectives. In the long term, it was the X-15 series of aircraft that merge aviation and space exploration. In today's terms, this is called aerospace. Our modern-day space achievements can be traced back to the test pilots that were made of the right stuff. The aircraft in focus this time is the Consolidated Aircraft Company's PBY Katalina. Like most illustrious planes of the bygone eras of great wars, the Catalina's creation can be found in the aspirations of one of aviation's great pioneers. This is 1918 in the United States, and it is the day that the airmail service begins. Such was the importance of the event that President Wilson attended to witness the posting of the first letter. The pilot of the aircraft was Major Reuben Fleet. Fleet went on to form the company that produced the Catalina and many other outstanding aircraft. The corporation was Consolidated Aircraft Company, which he based in Buffalo. But by 1936, he had moved the company to this site in San Diego, California, to build the Navy's new flying boat. It is interesting to note, at this point, all other seaplanes were biplanes. The Katalina was the first mono-wing to take to the water and the air. The original model was flown in 1933. Although there was a number of versions produced, it is the model number 5 that is most recognised, as it was produced in larger numbers and was the most used during the Second World War. The PBY Katalina took over from the earlier bi-wing flying boats, and two models were formed: the true seaplane and an amphibious craft that had retractable undercarriage that allowed it to land on both the sea and terra firma. It was designated as the 5A model. There were obvious advantages with the 5A model. However, they were slower, heavier, and subsequently had a reduced range. As soon as Britain received the Katalina, they were immediately pressed into the service as submarine hunters. The Katalina had a range that exceeded 4,000 miles, and this permitted the Katalina to escort convoys much further than was previously possible. The Katalina was the first real weapon that assisted in keeping the sea lanes open. The effectiveness of the Katalina was vastly improved when the first British radar system was installed in the North Atlantic squadrons. Once detected, the Catalinas would assault the submarine with bombs or depth charges. The factory continued to build the PBY-5, nearly right through the war. The PBY-5 was so successful that even as later models became available, the 5 and 5A model still maintained healthy orders. The PBY's construction was a mixture of boat building and aircraft manufacture. The wing, which was perhaps the most important part regarding the PBY's success, was built from steel and hand-stitched canvas. The combination of cloth and metal gave the wing strength, and the linen contributed to the lightness of the construction. The wing was then coated with a special aviation dope that stretched the cotton tight and bonded the two materials together. The assembly of this consumed hundreds of hours of demanding craftsmanship. Another feature of the PBY's wing was its retractable wingtip floats that could be raised during flight to reduce drag and improve the aircraft's handling characteristics. The large wing of the PBY was the secret to the plane's success. It provided great lift and held the plane's entire fuel load that would give the PBY its legendary long-range capability. Another interesting fact is the dry climate of California permitted the construction of some aspects of the PBY, such as the fitting of the wings to be completed outdoors. This saved the company from having to build thousands of square feet of roofed factory space. Tens of thousands of rivets were required, and Consolidated's rivet machine produced about 1 million rivets a week. Due to the stress of landing on water, the hull needed more attention to detail than other planes of this vintage, and the plating had to be watertight. The rivets needed special attention to ensure the tightest fit. They were frozen until required. When pressed in cold, they would warm and expand and ensure a tighter than standard fit. the craftsmen at the Consolidated Manufacturing Facility were as much boat builders as they were aircraft builders. The fuselage had to pass a watertight test. Since it wasn't feasible to build a water tank for testing the integrity of the fuselage, rather the fuselage was filled with water and checked by inspecting the outside surface instead. The centre spar was a unique design for its time, as it housed the flight engineer. Normally he would sit behind the pilot, but in this plane he sat above the pilot and was indeed very close to the engines he monitored. The PBY-5 was ordered in December 1939 and had an improved power plant of two Pratt & Whitney R1830-82 double wasp engines rated at 1200 horsepower, compared to the PBY-4's 1050 horsepower plants. Just 4 bolts held the engines to the wings. Nearing the final stage of construction, the aircraft was painted. Probably one of the greatest achievements of Boeing, which allowed it to become the giant it is today, was the development of the Dash 80. It was the prototype for the 707 passenger jet and the KC-135 jet tanker, and it became the first member of the 700 family of commercial and military jets. "72-year-old William Boeing came back to visit his former company for the rollout of the Model 367-80 on May the 14th, 1954 at the Renton, Washington plant. His wife Bertha christened the yellow and brown plane with real champagne, and the Renton High School band played the Air Force theme. The Boeing company had invested $16 million to build this prototype for a long-range jet aircraft. It was developed over 2 years in secrecy and designated Model 367-80 to disguise it merely as an improved version of the Stratofreighter. When the Dash 80 was almost finished, Boeing took another big gamble. They tooled up and geared up for a production aircraft, although neither the Air Force nor any airline had placed a single order. Constructed to sell first as a military tanker transport, it had few windows and no seats, but had 2 large cargo doors. A week after its first flight, the Air Force ordered 29 tanker versions, the KC-135. The commercial version, the 707, however faced tough competition from the Douglas DC-8. Boeing salespeople directed their efforts to Pan American, Trans World Airlines and large European airlines. Amazingly, the Dash 80 remained in service with Boeing for 18 years as a test plane, and in 1972 it was retired and turned over to the National Air and Space Museum. It sat idle in the Arizona desert for 18 years. In May 1990, under an arrangement with the Smithsonian, Boeing returned the airplane to Seattle for a full restoration program. A crew was sent to the desert to ready the Dash 80 for its final flight. It was a painstaking task that took 15 technicians 1,000 man-hours to bring the plane back to flying condition. But the desert had preserved the plane well, and the airframe remained in excellent condition. The Pratt & Whitney engines were fired up and tested, and when everyone was sure the Dash 80 was ready, the flight crew boarded and flew her into her birthplace in Seattle, where she was restored and ready to begin a new life of service. A service of reminding future generations of our steps in the achievement of flight. The last step in the restoration program was repainting the Dash 80 in her original colours. This was the last any test would be done in the aircraft. Fittingly, her paint job was a first in the world. It was a test of a new technique and procedure of painting aircraft. The Smithsonian to be one of the 12 most important planes in the history of flight. It revolutionised air travel. The Dash 80 was the plane that tested many of the revolutions we as travellers enjoy today. The Dash 80 established the classic configuration for jetliners to come. It also set speed records nearly every time it flew. Its swept-back wing design is used on nearly every plane today. The Dash 80 flew with a fifth engine mounted on the aft fuselage in a program to test the feasibility for a tri-jet 727. The Dash 80 had 3 different types of engines installed at the same time. The Dash 80 has approximately 3,000 hours of flight recorded in its logbook. Although it led a revolution in air transportation, the Dash 80 never entered commercial service itself. It was always a one-off development plane. However, the gift of the Dash 80 is the birth of much larger, faster and smoother planes that quickly changed the face of international travel.